Hello, this is Geometry Chapter 2 and Chapter 3 Review. I'm going to go through each of these problems from these chapters. Your job is to make sure you can go through and do all these problems just as good as I can before you take the test. So print out extra copies and redo them as many times as it takes before you can do them with no mistakes at all, and then you'll be ready for the test. So let's get started. The first is going to be to determine if the following lines have the same length. So line CD and lines EF. See if they had the same length. So we're talking about the distance of each of those lines. Let's get a little in closer. So CD, let's start writing. CD is right here. And there's a couple ways of doing this. There's a distance formula, but we can also just find the rise and the run and see if they're the same for both and calculate the distance that way. So here we're going to have a run of 4, or negative 4, or a rise of 4. Let's see here. And then we're going to have a run of 1. So in this case, CD is going to equal the square root of negative 4 squared plus 1 squared. So we'll have 16 plus 1 square root. So CD is going to equal the square root of 17. And we can leave it just like this. We do not need to round it, although it would be just above the square root of 16, which is 4. So this would be about 17 or 4.1. Now we're just going to see if EF is the same length. So let's do EF over here. So EF, right here, has a run of 3, rise of 2. So you might already be able to tell that they're not going to be the same, but show the work anyway, just to be absolutely sure. So we got 3 squared plus, try that again, 3 squared plus 2 squared, which will equal 9 plus 4, square root of 13. So we can clearly see between these two that they are not equal. And it is required that you show the work for both to prove it, not just say that you know that they're not equal for sure. Got to write it out. All right, let's do one more. Do the same thing, but for GH and JH. So GH, looks like we got a rise of positive 2, a run of 1, 2, 3, 4. So GH will equal 4 squared plus 2 squared, which is 16 plus 4, which equals root 20. All right. And lastly, we have JK, which has a rise of negative 4 and a run of 1. So we have 4, or negative 4 squared, plus 1 squared. We'll have 16 plus 1, which is the square root of 17. So these two are clearly not the same, therefore neither have the same length. However, if we did have to find one pair, it looks like CD is root 17, and so is JK. So at least those two are equal to one another. All right, so anytime you see length, think Pythagorean theorem and distance formula. All right, let's go down and look at a few more, just without a picture. So if we've had to find the distance between just the pairs with no graph, we can use that distance formula as well. We just have to know, well, how far is negative 3 from 0 for the x's? Right, how far is that? Negative 3 to 0. That would be 3 away. Okay. And then how far is it from 2 to negative 8? Right, that would be 10 away. And we can get those by subtracting if we want. Do 0 minus -3 is +3. -8 minus 2 is -10, which of course when we square these, the negatives don't matter. And we can go ahead and solve this. So we have 9 plus 100. So this is going to equal the square root of 109. And that's good enough for our answer for these problems. We do not need to approximate or get a decimal for those answers. Okay. Let's go ahead and find the midpoint. So switch gears a little bit. That's the middle of each of these x's, pairs of x's and pairs of y's. So what is the middle of 5 and 2? You can get that by taking the average. So the middle of 5 and 2 is 5 plus 2 divided by 2. The middle of the y-coordinates, what's the middle of -3 and +4? So -3 plus 4, and find the middle by dividing by 2. So just remember the midpoints is like the average. Just do the x's separate from the y's. So we'll have 7 over 2, 7 halves, and looks like 1/2. And you can just leave those in fraction form. If you really want to, you can convert that to 3.5 and 0.5. Okay, let's keep going. I'm going to do some linear pair review. So just remember linear pair. Every time you see that, you got to think that's 180 degrees. All right. So let's draw a graph just to be complete here. So we have 180 degrees and a pair of angles on 180 degrees. Let's draw that right on there. And this is just a estimate. I don't know if this is the correct angle or not. Here. Okay, let's label our points. So we have F, G, and Z up here. FGZ is 2x plus 23. Okay, now we have ZGH, ZG, and then here's H over here. This will be 4x plus 1. So these two angles, we already know, are a linear pair, so they add up to 180. So we need to solve the equation that adds those two up and equals 180 degrees. Equals 180. Right? So we have a couple of x's here, so 6x from 2x and 4x. And then we have 23 plus 1, which is 24, equals 180. And then do a little two-step equation solving. Subtract 24 on both sides. So we'll have 6x equals 156. Divides both sides by 6, and we'll have x equals, looks like 26. And the directions do call for us just to find x, so I've done that, so I am finished. X equals 26 is our answer. All right, let's go over to 6, which is a perpendicular bisector. Looks like, or just a regular bisector, yeah, angle bisector. Okay, so let's draw an angle. Draw a bisector. Bisector means splits in half evenly, right? We can label these. It says ray PQ is a bisector, so I know this is my ray PQ. of RPS, so this must be R, P, then S. Okay. We know the measure of this whole angle, RPS, entire angle is 50. And the measure of RPQ is 2x plus 5. Okay. We want to find the value of x. Now, since this is a bisector, this is important. A bisector means both these angles are equal, congruent. So if this is 2x plus 5, so is this, 2x plus 5. So we have two of these. 2 of the 2x's plus 5 added together will add up to the whole angle, which is 50. So there's our algebraic equation we need to solve. You can do this two ways. You can distribute the 2 and get 4x plus 10, or you can divide by 2 on both sides and get 2x plus 5 equals 25. And most of you will probably choose to distribute, so we'll do it that way. There we go. So I'm going to subtract 10 on both sides. So I'll have 4 times x now equals 40, 50 minus 10, and divide both sides by 4. So I'll have x equals 10. All right, here we go. There's my answer because they were asked to find x. If we want to plug these back in, we can double check and see if they work. Like these, both of these have to add up to 50. So if you plug them back in, you'll have 2 times 10 is just 20, and 20 plus 5 is 25. And since they're the same, it makes sense that each of these are 25. So you can always do a check to make sure all your numbers do add up correctly. All right, let's switch gears to component form. Okay, component form means you use these type of pointed parentheses. We want to know for mapping JKL, which is right here, to J prime, K prime, L prime. We want to see how far left and right do we have to move and up and down do we have to move. So I'm going to use, I can use any of these points. Let's go with L and L prime. In order for L to go from x equals 8 to x equals negative 4, right, looks like I'll have to move to the left. From positive 8 to negative 4 would be moving left 12. So that's the first part of my vector. And then I'm going to need to move down. Right? I'm at positive 2. I need to go to negative 4. So from positive 2 to negative 4, that's down 6. All right. There is my component form of the vector. That's all you need to do. It's synonymous with doing this. X minus, in parentheses, x minus 12. Right, this is called coordinate form. Y minus 6. Okay. These are the same thing. You really just leave out the x and the y and use pointed parentheses, and you have the component form. All right, let's keep on moving. We're on to number 8. All right, using this vector, we're going to draw the image. Remember, this is called a pre-image, so we want to draw the image, which will be A prime, B prime, C prime. And this tells us we want to move each of these corners. Looks like to the left, 1, 2, 3, 4, 5, and down 2, 1, 2. Each of these we just move left and down 2. So left 5, 1, 2, 3, 4, 5, down 2, 1, 2. This is A prime. Okay, 1, 2, 3, 4, 5. Down 2, 1, 2. There's C prime. And then lastly, 1, 2, 3, 4, 5, and down 2, 1, 2. There's B prime. All right, and then let's go ahead and draw the image, which is of course a rigid transformation, so it should be the same size and shape when you're finished. There we go, that's all we need to do on number 8. And number 9, we got to draw this and then use this vector here to translate it. So very similar to the last problem, it's just not graphed for us. So 2, 4, this is A. 1, 2, here's B. And 4, 2, here's C. Okay. Now let's go ahead and translate this. This is going to be left 4 and up 1. So each of these points, like the last problem, left 4 and up 1. 1, 2, 3, 4, up 1. B prime. 1, 2, 3, 4, up 1. A prime. 1, 2, 3, 4, up 1. And here's C prime. There we go. There is our image of ABC. Okay, let's do just one more of the same for extra good practice. So PQR. P is at 2, negative 1. There's 2, negative 1. And we have Q at 2, negative 3. And down here. And R is at 4, negative 3. R, Q, P. There we go. And we want to go left 3 and down 1 for our vector translation. So 1, 2, 3, down 1. That's P prime. 1, 2, 3, down 1. There's Q prime. Then 1, 2, 3, down 1. Here's R prime. All right. There's our practice with component vectors. Move on to number 11 now. Let's do some transformations. So let's start by graphing these, plotting these points. So 3, 4. There's S. 3, 1. Here's T. Negative 2, 1. Negative 2, 1 is over here. There's U. And negative 2, 4. So there's V. So it looks like we have a rectangle. And we want to reflect it over the x-axis. So here's the x-axis. So we're going to reflect it right over here. So a couple ways of doing this. You can use a sheet that has these transformations on it. And according to that sheet, our reflection over the x-axis is the x staying the same, but the y's are going to be the opposite, which kind of makes sense. Once we reflect this point, for instance, over the x-axis, it goes down here, and the x-coordinate is still 3, but now the y-coordinate is negative 1. Instead of positive 1, it's now negative 1. So it just follows this. Take the opposite of each of the y-coordinates, leave the x-coordinate alone. We can keep on doing that. This is 3, 4, right? So I want to go to 3, negative 4. There's S prime. This is T prime. And we have U, which is negative 2, 1. So negative 2, negative 1. That's going to be U prime. And V, which is negative 2, 4, will be negative 2, negative 4. There we go. And there is our reflection. Okay, let's do another, number 12. Very similar. Going off of our cheat sheet, we're going to go across y equals negative x, which is this line that's diagonally going down through your graph. So we're going to reflect about that line. And according to our sheet, this is going to transform by taking the opposite of both variables and then transposing x and y. So everything switches about this, the location and the sign. Let's go ahead and plot our original pre-image. A is -4, -2. There's A. B is -1, -1. There's our B. C is -1, -4. So we have a triangle. All right, so we write these down. We have A, which is -4, -2. That's going to transform into, remember, the opposite of both and then switch them. So we're going to go to +4, +2, and then switch it to +2, 4. So 2, 4 up here will be A prime. And B, which is starting off at -1, -1, take the opposite of both, +1, +1, and then switch it, which will not change it, so 1, 1. So here's our B prime. All right, let's go. Lastly, we'll do C, which is -1, -4. So we'll have +1, +4, and then switch them, 4, 1. There's our C prime. And then we can go ahead and connect it. There we go. Okay. Do just one more, this time reflecting across the y-axis. Okay, this is right down the middle. I'm going to do this one by just counting the squares. So you can see how H is just one away from our line of reflection, which means H prime will be one away from our line of reflection on the other side. So this will be H prime. And then C, we can see here is 1, 2, 3. I'm going to go 1, 2, 3. There is my C prime. Same thing with M, which is 2 away. 2 away, M prime. A, which is 4 away. So 4 away will be A prime. The reflections across the axes are a little bit simpler to do informally without using the transformation paper. But when we have the -x and the y = x, it's probably better to use these. All right, let's flip it over. Go to 14. All right, draw the line of reflection. So we have both the image here and the pre-image, and we need to find where exactly it's reflected. Now, let's go back to the last problem to help us out. Notice how the line of reflection goes down the exact center of each of these. It's in the exact middle of H and H prime, M and N prime, and so on. So it's like the line of the reflection is a midpoint. There's a bunch of midpoints. So that's what we're going to do here. Since we have both images, we're going to find the midpoint at least 2 times to draw that line. So let's find the midpoint of A and A prime. Okay. A looks like 4, 7. Right? And A prime looks like 6, 3. So let's find the midpoint of A and A prime. Midpoint will be, remember the x's, it's the average. We'll find the middle of 4 and 6. Now you might already know that the 5 is the middle of 4 and 6, but we can show it anyway. And the middle of 7 and 3. So we're going to add these up and find the middle by dividing by 2. So the midpoint will be 10 divided by 2, which is 5. Again, we probably already knew that 5 was the middle of 4 and 6. The middle of 7 and 3 is going to be, again, 10 divided by 2, which is 5. So one midpoint we have is at 5, 5. Then we need to do at least one more time. Let's do it with B and B prime. So the midpoint of B and B prime. B looks like it's 3, negative 1. B prime looks like it is negative 1, 7. So let's find the midpoint of the x's, so 3 and negative 1. Divide by 2. And the y's, 7 and negative 1. So 3 plus negative 1 is 2. 2 divided by 2 is 1. 7 minus 1 is 6. 6 divided by 2, 3. So 1, 3. All right, there we go. Now we for sure can draw a line through these, but if you want to be extra sure, since it's a test, I would recommend go through and find out what the midpoint of C and C prime is. Okay? But for this, we're actually just going to connect them. Shape. There we go. There we go. There is our line of reflection. Okay, so one more time, just extra practice is always good. Okay, at least 2 points. So let's do C and C prime. I can do this one a little faster. So the x's are negative 1 and negative 3. Negative 1 plus negative 3 divided by 2. The y coordinates are negative 3 and negative 1. So actually the same. Negative 3, negative 1 divided by 2. So we have negative 4 divided by 2 is negative 2. Negative 4 divided by 2 is negative 2. Our first midpoint, that negative 2, negative 2. Just right there. Even though we could probably figure that out by looking at the graph, still show the work and proof for that answer. All right, same idea here. We could probably tell that right here is the midpoint of B and B prime, but you need to prove your work, prove your answer. So if we already know the answer is 2, 2, it shouldn't be that much work to just prove it. So very similar. We have 3, 1, and we have 1, 3. So the x's are 3 and 1. It's very familiar, doesn't it? Divided by 2. And my y's are 1 and 3. So we get 2, 2. So that ensures we have our answers correct. There we go. There's our line of reflection. If you want to be extra sure, you can always go through and find the midpoint of A and A prime. All right, so let's go ahead and move on and do some rotations. I'm going to write these out and be extra careful because rotations tend to be tricky. So by writing out, I'm going to list my coordinates on the side and make a table. So it looks like we got 2, 1. For Q, looks like we got 4, 1. And for R, we have 4, negative 3. Okay. And using your pink sheet or your other sheet, we got, let's see, our transformation for counterclockwise. We're going going to be going from the first quadrant over here, second quadrant, counterclockwise, 90 degrees. It's going to be starting at x comma y. It's going to transform to negative y comma x. That's just from my paper. So I'm going to write these out very carefully here. So I'm going to transpose x and y and take the opposite of y. I'm going to go from 2 comma 1. If I transpose it, it's going to be 1 comma 2. And then take the opposite of the y, which was 1. So that will be my p prime. Negative 1 comma 2. Negative 1 comma 2. And just repeat that process. So q prime, transpose 4 and 1 would be 1 and 4, and then take the opposite of the y. So negative 1 comma 4. Negative 1 comma 4, which is up here. There we go. And lastly, r prime. So we'll have negative 3 comma 4, take the opposite. So I have 3 comma 4. 3 comma 4. There we go. So there is our transformation. Looks like I missed q here. That was negative 1, 4. There we go. So that is our 9-degree rotation, counterclockwise. Go to 17, and in a similar way, I'm going to write things out. We'll be very careful about these. So let's start just by writing out D, E, F, G, and writing out our coordinates. D, E, F, and G. So D is negative 3 comma 1. E is negative 1 comma negative 1. F is negative 1 comma 1, 2, 3, 4, negative 1, negative 4. G is negative 3 comma negative 3. Okay. And we want to go clockwise. So we're going direction of a clock, which is this way. Now your paper only gives counterclockwise rotations. So we need to know that a 90-degree clockwise rotation is the same as going all the way around to end up here. That's a 270 counterclockwise rotation. So I'm going to use the equivalent, which is a 270 counterclockwise rotation, which is on your paper. So that's going to be x comma y. It's going to translate to y comma negative x. Okay, so here we go. Again, we're going to transpose them and take the opposite of x this time. So y will stay the same. If we want to, let's just go through, do this a little differently. Since y is staying the same, I'm going to rewrite the y coordinates first. So I have 1, negative 1, negative 4, and negative 3, all staying the same. My x coordinates are the ones that are going to take the opposite of. So I have negative 3, which becomes positive 3. Negative 1, which becomes positive 1. Negative 1, again, is positive 1. Negative 3 is now positive 3. There we go. So those are my rotated coordinates. Graph those in pink. So we have 1 comma 3. For D prime. Negative 1, positive 1. So there's E prime. Negative 4, positive 1. F prime. And then G prime will be negative 3 comma 3. And then connect these. And it should be the exact same size and shape. just rotated. Right? There we go. Lastly, let's do a 180-degree rotation. Now, there is no clockwise or counterclockwise. It doesn't matter which way you go if you rotate this way or this way. 180 is the same thing, either direction. So our transformation will be, according to our cheat sheet, x comma y will translate to the opposite of x and the opposite of y. So f, which is negative 1, 2, 3, 4, comma positive 2, will translate to 4, negative 2. So 4, positive 4, negative 2. So there's f prime. Then we have h, which is negative 2, comma 0. This will translate to positive 2, comma 0, just on the other side. Here's my h prime. And then lastly, my k prime, which is negative 4, comma negative 3. Will translate to 4, comma 3. 4, comma 3. There's k prime. So it's almost like a reflection, but not really, because k is down here and now it's up here. So it kind of looks like a reflection if you look at h only, but really it's a rotation. All right, let's continue. Doing really good. Building endurance. Go to number 19. Let's start by choosing some points, and we're going to measure that angle with a protractor. It doesn't matter which 2 points you pick, as long as it's the image and pre-image. So I'm going to go with, let's say, N. So I want to draw some rays from point P through N, and then another one from point P through N prime. Okay? And this is the angle right here that I want to measure. I want to find out what this measurement is. Pull out a protractor. And do my best to line up one of these sides. There we go. Looks pretty good. Do a little more. About there. And we can see this is an acute angle. So I'm not going to use these bigger numbers, right? I know it's going to be less than 90 degrees, so that means I need to use these right here. So here's 10, 20, 30, 40, 50, and 60, 70. It looks like about 80 degrees, maybe plus or minus a little bit from 80 degrees. But I'm going to go with 80 degrees. That's very, very close. And I won't mark you off if you're pretty close to that as well. So we're going to go with 80 degrees. Close this. Okay. And I just did this, and found out that this was 80 degrees, roughly. Okay, let's continue on to number 20. Here we have multiple transformations. We just have to be careful and write out a table when we're doing these to make sure everything is perfectly accurate. So we got point A. Let's put that down just a little bit. Is 2, 2. Okay. And then we have point B, which is 2 comma 5. Point C, which is 3 comma 2. Okay, so we have, these are our x and these are our y's. We have to go through each one of these transformations. So the first one we're going to do is just reduce each of those, x and y, by 1. We're just going to go step by step. So we'll have 2 minus 2, 2 times. So we have 1 comma 1. We'll have 2 minus 1 and 5 minus 1. Then we'll have 3 minus 1 and 2 minus 1. And there's our first round. And we keep going. Now we are going to multiply x by 3, but keep y the same. Okay, so a dilation of 3. So 3 times 1 is 3, y stays the same. 3 times 1 again, y stays the same. And 2 times 3, y stays the same. And then lastly, we're going to take the opposite of x and y. Opposite of x, opposite of y. So we'll have negative 3, negative 1, negative 3, negative 4, and negative 6, negative 1. So I'm going to go ahead and plot those 3 coordinates. Negative 3, negative 1, negative 3, negative 4, and negative 6, negative 1. There we go. That is our transformation. All right, let's practice one more of these. Again, same thing. Start by writing down the coordinates. A is at 2 comma 1. B is at 0 comma 2. And C is at 4 comma 3. So our first transformation from xy is going to be to 3 halves x and negative 2y. So step by step, 2 times 3 over 2 is 3. 0 times 3 over 2 is 0. 4 times 3 over 2 is 6. Okay. And now negative 2 times y, so we have 1 times negative 2, 2 times negative 2, 3 times negative 2. There is our first transformation. And lastly, we are going to subtract 5 from each x and add 4 to each y. All right, so 3 minus 5, negative 2. 0 minus 5, negative 5. And 6 minus 5 is positive 1. Okay, now add 4 to each y. Negative 2 plus 4 is positive 2. Negative 4 plus 4 is 0. And negative 6 plus 4 is negative 2. So here are our transformed coordinates. Negative 2, comma positive 2. Negative 5, 0. And 1, negative 2. There we go. Our transformed image. All right, let's keep on going. Almost done. 22. There we go, 22. Bring down the zoom. Start this by just writing down the points, coordinates for each of these figures. So JKLM. However, J is going to be, looks like at 6, 2. K is going to be at 8, 2. L looks like 6, 6. And M looks like -2, 6. Right, and then let's also write down where we're going to end up. So we know that J is going to map to W. So I should have W here. We have -2, -4. Right. K will map to X. So X will be 4, -4. W looks like it's positive too. Okay, 4, 4. Glad I caught that. Yeah. And then L will map to Y. So we have +2 and -2, 4, 6, 8. So 2, 8. And then lastly, we have -2, 4, 6, -6, -8. And this is Z. All right, so I want to find out what transformations it takes in order to transform each of these points to their image, each of these preimage points to their image point. Right? So by looking at this graph, we can probably tell that we need to do a reflection at some point, that we need to get these points to come together. So the first thing I want to do is probably reflect this over the axis, and imagine you're trying to remove this to this side by reflecting it over the x-axis. So we're going to do that first. It's not going to be perfectly lined up, but it'll be much closer. And that's going to be the x-axis. Reflection, x-axis. There we go. All right, and that rule is, according to our paper, xy will map to x, -y. All right, so I'll go ahead and do that here. So we'll go to each of these x's will stay the same, and I'll just have a -y. So I have each of these points with a -y. Okay. Now we just need to come up with a rule. I know I need to slide it over a little bit, do some translating. So I'm going to do some translation. I don't know by how much yet, so I'm going to use the numbers to help me out here. So I need a single rule that works for all of these, go blue, that takes me from 6 to 2, 8 to 4, 6 to 2 again, and -2 to -6 by adding and subtracting. So after a little bit, you can probably figure out I need to do 6 minus 4, 8 minus 4, 6 minus 4 again, and -2 minus 4, and that'll give me each of these points. So my first translation is x minus 4. Then let's do the same thing for y. I need to do what gets me from -2 to -4 twice, -6 to +8, and -6 to +8. Single rule that works. So it looks like -2 plus 2, well, -2 minus 2 will give me -4. -2, let's see here. -2 does not work here, though. Let me double check my coordinates. Let's see here. X, is that 4, -4, +4? X is 4, -4. Okay, so I have some missing numbers here. And it looks like I have it missing here as well. So it should be -8 and -8. And now my rule will work. So it's a good thing I'm checking all of these. So -2 minus -2 minus 2 is -4. -6 minus 2 is -8 twice. Okay, so our rule here is going to be y minus 2. So a good reason to check everything just in case you miss something. It should check out in the end. So there is our translation. All right, let's keep going. Do a few more of these. Good practice. Now there are 5 points here for the pentagon. I don't know if there's enough room for all 5, but if it works for 4 of them, it's probably going to work for the 5th. So we really only need to do, let's say, the first 4 here. That'll give us a good enough sample to get the right answer. So let's do A, B, C, and D. All right, and those are going to map to P, Q, R, and S. And just like before, let's get all the coordinates down. So for A, B, C, and D. So A looks like it's -2, +4. B looks like it's +2, +2. C, we got +4 and +4. And D, we have +2, no, +1. So that's right in the middle. So +1 and then 2, 4, 6, 8. 1, 8. All right, and where we want to end up is at P. So we're going to be at +2, -6. Q looks like -2, -2, 4, 6, 8. So -2, -8. R, which is -4, -6. -4, -6. And then S, which is -1, -2. There we go. There's a couple ways of doing this. Let's try to reflect it over this axis first. So I want this side, the BC and the D, I can tell that need to map to these 3. So I'm trying to get these 3 points to map to these 3 points. So that lets me know that I probably should flip it over or reflect it over the y-axis to start off with. That way these points will be on these side and this E and A will be on the other side. So let's do that. Reflection over y. Axis, which is -x, y. So let's apply that transformation to each of these. So I'll end up with like 2, 4, -2, 2, -4, 4, and -1, 8. Just took the opposite of each of the x values. Okay, good. And let's look at what do I need to do to get from here to here for my translation. As you can tell, there's no difference. So for my translation, at least for my x coordinate, the x coordinate does not need to change. Stays the same. For the y-coordinate, we got to go from 4 to negative 6, 2 to negative 8, and 4 to negative 6, and 8 to negative 2. So each of those is subtracted by 10. 4 minus 10 is negative 6. 2 minus 10 is negative 8. 4 minus 10 is negative 6 again. And 8 minus 10 is negative 2. So I'll have y minus 10. All right. One more to go. All right, let's continue on to 24. Looks like we're going to need to map MPN to J, L, and K. I'm going to end up at J, L, and K. Let's get those coordinates down for both our pre-image. So we have negative 4, comma 2. For P, we have negative 1, comma 2. And for N, we have negative 1, comma negative 3. And we want to end up at J, L, and K. So J, we have 4, comma 5. L, we have 1, comma 5. And K is 1, 0, 1, comma 0. All right, we could probably see what we're going to do here. We need to move this figure up, translate it straight up, and then probably reflect it over the y-axis. We can do that in any order. So let's go ahead and do the reflection first over the y-axis. Okay, y-axis. And of course, we've used this already before. This is where we take each x and take the opposite, keep the y's the same. So we'll have 4, comma 2, and we'll have 1, comma 2, and then positive 1, comma negative 3. And then we'll need to translate up. And you can see here that all my x's are going to stay the same in my translation. All right, this is the translation. But my y values, go for 2 to 5, 2 to 5, negative 3 to 0, are all raised or by 3. There we go. All right, let's go on to our symmetry, rotation symmetry. We're going to see which ones have what kind. So let's switch to. We can see here that we have several lines of line symmetry. That if we just put a line down the middle, both of these, if we folded along that line, they would fold onto themselves. And we can also do this probably diagonally as well. So it looks like we have 1, 2, 3, 4 lines of symmetry. Now we also have the rotational symmetry, where if we just rotate each of these probably 90 degrees, if I rotate this 90 degrees, it would end up over here right on top of this one. So it looks like we have rotational symmetry as well. We can do 90, could do 180, and then we could do all the way here 270. So we have 4 lines of symmetry. Try that again. 4 lines. And then we have some rotational symmetry of 90, 180, and 270. Next, we look at this one and ask yourself, is there any line you can draw where if you folded along that line, that these two would end up lining up? So after a little bit of consideration, you'll probably notice that that does not exist. We cannot fold this in half and have this part fold onto this part. However, we can rotate this all the way around so that that part is now onto this part. So that would just be a 180-degree rotation only. Okay, next we have, looks like we can draw a line of symmetry here down the middle. Right, so if we fold this half will fold exactly onto this half. You'll notice that if we draw a line here, that this half will not fold onto this half. So this is not going to be a line of symmetry. We're only going to have one. Let's see here. Yeah, so we want to. All right, so we only have that one line. We got one line here. Here, you can ask yourself, is there any way to fold this as well? Let's get back to here. Right. And you could probably tell that if we fold right down the middle here, that this half would fold exactly onto this half, which means that will work for any of these. So we got 2, then 3 lines of symmetry. And then we can probably rotate it so that each of these points will rotate onto one of these points. So since we have 5 points here, rotational will be 360 degrees divided by the number of rotations. So we have 360 divided by 5, which will be, I believe, 72 degrees. So every multiple of 72 will be a rotational symmetry. All right, let's go on to our last page here, where we just have to talk about the congruencies of triangles. So this is from the idea that congruent sides of congruent triangles are congruent. Same thing with angles. Congruent angles from congruent triangles are congruent. So for each of these, we're just listing, based upon the order that these are listed, we'll know that angle A and angle W are congruent. And we'll know angle B and angle X are congruent. And then we'll know angle C and angle Z are congruent. Go. And so the angles are congruent, but so are the sides. So AB, the first 2 letters, is congruent to WX. So the segment AB congruent to WX. And then, see here, we got the second 2, BC and XZ. So we say BC segment is congruent to segment XZ. Okay. So blue. And then also the first and the last. So AC is congruent to WZ. And then we can do this with any shape, not just triangles. So we can do the same thing here, but with rectangles, just using the first. The first always corresponds to the first, and so on. It looks like we have, let's see, 1, 2, 3. We can't have something repeating here, so let's go L, M, N. Let's use this as O instead of N. We can't have N twice. So the first are congruent, angle T and N. The second are congruent, angle S and angle L. Angle U and angle M. And angle V and angle O. Okay, the first 2, we have TS is congruent to NL. We'll do the second two. SU U is congruent to LM. And the last two, UV, is congruent to MO. And then the first and the last, TV, is congruent to NO. Okay, good. Let's see here. And lastly, we just have a few problems here to use congruent triangles to solve. So the first one is we want to find the measurement of SU. So we can find what SU is congruent to. SU is the first and the last of this triangle right here, right? So I'm going to use VX. That's what it's congruent to. SU and VX must be congruent or equal. SU and VX. We have SU is equal to VX, and VX is 43 feet. Very good. Measure of angle S. S is congruent to V, measure of V, angle V. Angle V, there we go. And angle V looks like it's right here. These two are congruent, so that's going to be 38 degrees. All right, and lastly, some with a little bit of algebra. So we want to find LM, which is the first two here, so it must be congruent to GH. So here's GH, here's LM, so those are equal to each other. Now LM is 6x minus 13. And GH is 4x plus 3. We go through and solve this. Subtract 4x on both sides. And add 13 on both sides. We get 2x equals 16. So that must mean x equals 8. Now that we know x is equal to 8, we need to still find what LM is. So here's LM, 6x minus 13, so that would be 6 times 8 minus 13, which is 48 minus 13, which will equal 35 centimeters. Good. And then we can find measure of angle H. Here's H here, which will be congruent to M. So here's angle M and angle H. So H equals, let's go a little darker. H equals 9y plus 17. M equals 11y minus 1. We can solve this. I'm going to subtract 9y on both sides. And I'm going to add 1 on both sides. So we get 18 is equal to 2y. And we solve that, we'll get 9 is equal to y. Okay, so here is my angle H that I'm trying to find. It's right here, so I'll plug 9 into this. I'll get 81 plus 17, which is 96, actually, 98. Try that again. 81 plus 17, which is 98 degrees. There we go. And that's our final answer. All right, that concludes this review. Remember, you want to be able to do each of these problems by yourself with no help, but not looking at the answer key, and still get 100%. So print out as many of these as you need to be able to do that, and you'll be ready for your quiz. Good luck.